All right, so we're going to talk about area formulas. We're going to give our formulas for area formulas for triangles, parallelograms, and trapezoids. Thank you. All right, so what I'm going to do on the notes is I'll draw the figures. You can label the figures in your flip book, and then we'll explain what the parts are, and then we'll write the formulas. So let's start off with triangles. So we'll draw a triangle here, and we'll label the parts. This doesn't look exactly like the one, won't necessarily look exactly like the one in your flip book, but that's okay. So we have a triangle, and I'm going to draw this segment in here. And we're going to make this a 90-degree angle. And the length of this side at the bottom here is B. And we're going to call this the base. Any side of the triangle can be the base. It doesn't have to be the one that's flat. We can have any side be the base. And we're going to call this red segment, this is going to be the altitude. And the length of that is H. We'll call it H, and we usually use the word altitude and height to mean the same thing. Altitude is the name of the segment, and height is the length. So they're a little bit different, but usually we use them kind of interchangeably to mean the same thing. So this segment is the height. The length of the segment is the height. It has to make a 90-degree angle with the base, and any side can be the base. And we would draw the height, draw in the altitude, depending on which side we chose to be the base. One important thing to remember is that the altitude can be outside the triangle. And we'll draw that.
Are we writing this in our book?
What I would suggest is you draw the picture that I draw here. A lot like underneath the triangle that you have there, so just so you understand. So what you should do is label your triangle that you have in your flip book, and then we'll do the formula here in just a second. But you have some room to draw this other picture. So the altitude can be outside. So let me draw a triangle where that altitude is outside. So for this triangle, I can draw the altitude. I'm going to extend this side, extend this bottom side here, and do that, like so. And I'm going to draw my altitude here. And we have a 90-degree angle. So on this triangle, the altitude is outside. And this would be our height, and this side would be our base. So now we're ready for our formula. And I think everybody knows this formula. How do we find the area of a triangle? Jalen?
A squared plus B squared equals C squared.
That's how we find the missing side on...
And then you do the...
So that's the Pythagorean theorem. No, that you're thinking you have to do a triangle, so that's. But you're thinking of finding the missing side. We're finding the area.
Base times height divided by 2.
Base times height divided by 2.
I just want to be
So I'll write it out in words first. Base times height divided by 2. We could also write that as b times h divided by 2. And that's the same thing. Just want to make sure we all understand this. This is the same as writing 1/2 b times h. 1/2 is the same thing as dividing by 2. So we can write any of these ways. And for these triangles, we have our base and our height labeled, so we understand what we're talking about. The perimeter. We don't have a formula for the perimeter of a triangle, but how do we find the perimeter of any shape? Add up all the outsides, right. So for any shape, to find the area, we just add up the sides. So our area for a triangle, base times height divided by 2. And for our perimeter, we add up all the sides. Any questions on that? Okay, we're going to go on to parallelograms. And again, what I suggest is you label your parts in your flip book, and then we'll come up with we'll write our formulas. So here's our parallelogram. And we're going to call this side the base, and I'll label it B. Any side can be the base. Doesn't matter which side we choose to be the base. And I'm going to put in my altitude, like we did for the triangle. I'm going to put it in here. And it makes a 90-degree angle with the base. The altitude has to make a 90-degree angle with the base. So this is our altitude. And we find, that's how we find the height. We'll label this H. And just like with triangles, our altitude can be outside the parallelogram. So let me draw another parallelogram, and we'll put the altitude of this one outside. So I'm going to extend the base just like we did before. And I'm going to draw my altitude down here. As long as it makes a 90-degree angle with the line that comes from the base, we're fine. And we'll label that one H, and this is B. Anybody have a guess to what our area of a parallelogram would be? Tim says base times height. Exactly like a rectangle. And I'm going to do a demonstration a little later why the formulas turn out the way they do, to help us see why they work out this way. And we can also write that as B times H. And our perimeter, We don't have a special formula for the perimeter of a parallelogram, but we can always just add all the sides. So there's our formula for parallelograms. So we have a few of our formulas filled in on our flip book. Any questions on parallelograms? Okay, let's look at trapezoids. So we'll draw our trapezoid here. Trapezoids are a little different, but not a whole lot different. So there's our trapezoid. I'm going to call this, label that one B1 and B2. The parallel sides of our trapezoids are the bases, just like we talked about before when we talked about trapezoids and we labeled the parts. And the sides that aren't parallel are legs. And we'll draw in our altitude. We need an altitude to find our area. And our altitude goes between the bases. And we have a 90-degree angle. So this is, we'll label this H. And that's our altitude. I'll rewrite that. And again, a lot of times we use altitude and height to mean the same thing. Height is our length, and altitude is the name of the segment. And again, the altitude has to be perpendicular to the bases. It has to make a 90-degree angle. And also, again, the altitude can be outside. So let me draw a trapezoid here, and we'll put our altitude outside this time. So I'm going to extend one of the bases like we did before. And then my altitude is going to go here. And that would be our height. This would be B1 and B2. So we can put the altitude outside a trapezoid also, as long as it's perpendicular to the lines that connect the bases. And our trapezoid, our area, is going to be, does anybody know the formula for the area of a trapezoid? You're close. It has to do with B1 and B2, so you're on the right track. So the area is base 1 plus base 2 times the height divided by 2. And if we just use our symbols here, this is going to be B1 plus B2 times H divided by 2. And this is the same thing as saying 1/2 B1 plus B2 times H. Multiplying by 1/2 is the same as dividing by 2. All of these things mean exactly the same thing. So we add the two bases together, multiply by the height, and divide by 2. It's a lot like we did when we talked about the mid-segment of a trapezoid. The mid-segment is the average of the lengths of the bases. So we're talking about the average length of the base, and we're multiplying by the height. Our perimeter. We don't have a special formula for the perimeter of a trapezoid, so what do we have to do? Add all the sides. That's going to be our fallback for finding perimeter. We can always add all the sides. For most shapes, we're not going to have a special formula. We're just going to add up all the sides. So now we have a couple pages of our flip book complete. Any questions on our formulas? All right, let's look at a couple of examples, and then I'm going to do a demonstration about why the formulas look the way they do. So for the first one, we have a triangle. The base is 15 feet, and the height is 22 feet. We want to find the area. How do we find the area of this triangle? Jay? Base times height divided by 2. So we're going to do 15 times 22 divided by 2. And if we multiply that out, we would get 165 feet. And how do I need to do my units? Squared, feet squared. Right, feet squared or square feet. Either one works. When we have area, our units are always going to be squared. Second example, let's look at a parallelogram. So here's my parallelogram. And this is 13 centimeters, and this is 17 centimeters, and this is 27 centimeters. We want to find the area of this parallelogram. Now, a mistake that people make often with parallelograms and trapezoids is they confuse the side with the altitude. So which one of these lengths is going to give us our height? The 13. The 13 gives us our height. It's perpendicular to one of the bases. Don't confuse it with the side length that's 17. So our area for a parallelogram, how do we find our area? 13 times 27, base times height. When we multiply that out, we get 351 centimeters squared. Always have square units with area. So a common mistake is to confuse this side with the height. So just be careful about that. Let's do an example with a trapezoid. This is another one where it's easy to confuse the side length with the height. So here's our trapezoid. And there's our right angle. And this is 12 inches. This is 3 inches. This is 8 inches. And this is 15 inches. So which length do we need to use for our height?
Well,
12. It's the one that makes the 90-degree angle with the base. So our area, how do we find our area of a trapezoid? B1 plus B2. So we have 3 plus 8 times 12, the height, and all of that divided by 2. So we get 11 times 12 divided by 2. Did I show you guys the trick on how to divide or how to multiply two numbers, multiply a number by 11? Have I showed you that? So Steve says multiply by 10 and then add the number back. So that's one way. But what did you say, Isaac? You split them. There's this really cool trick that you can do, and then we'll calculate our answer. So if we're multiplying 11 times 12, we split the 1 and the 2 and add those two numbers together. So 11 times 12 is 132. And it works for any two-digit number. If our two numbers add up to more than 10, so let's say we had, say, 75 times 11.
7 plus 5.
We would split the 7 and the 5. 7 and 5 is 12, so I'd put the 2 here, carry the 1, and I'd get 825. So it works for any two-digit number that you're multiplying by 11. It's pretty cool. So our answer here, now that we've taken this detour, is 132 divided by 2, which equals 66 inches squared. And that is our area of our trapezoid. Any questions on our formulas? All right, let me show you a quick demonstration, and then we'll go over our homework.